This video tutorial is going to take you through how to balance chemical equations, first of all using the notes that we did in class to give you a second look at that, and then we'll practice with some other examples. So the first thing that we started with here was the word equation for the electrolysis of water. You can tell that we have water with the condition of electricity, which, reminder, goes above the arrow. Will break down into hydrogen gas and oxygen gas, the components of water. The next step is to convert that to the skeletal equation. So all we're doing is changing the words into the formula. So water, as we all know, is H2O, 2 hydrogens and 1 oxygen. That is going to be in a liquid form. That's the common form for water at room temperature. The next thing we need to do is write in our arrow. Then we have hydrogen gas. Note that we're given the state. Remember that hydrogen, being a diatomic molecule, has to have the subscript 2 next to it to state that there are 2 hydrogen atoms in this one molecule. And then the state is a gas. Then we have our our oxygen, which is again a diatomic molecule. So again we have that subscript 2 stating that we have 2 oxygen atoms in this one molecule. This again is also in the gas form. Now, to balance a chemical equation, we need to write coefficients, which are large numbers that would go in front of the molecule and would multiply any coefficients within that molecule or ionic compound. In this case, we're just dealing with molecules because they are all non-metals. So one first way of doing this is to break down all the elements and count them up on both sides, the reactant sides and the product sides. So if I look at my little chart here, I've got hydrogen and then I've got oxygen. On the reactant side I have 2 hydrogens and I have 1 oxygen. On the product side I can see the 2 hydrogens, and I've also got 2 oxygen atoms. Remember, these are I'm no longer counting the number of molecules, the subscripts are counting the number of actual atoms. And as we know from the law of conservation of mass, the mass of the reactants equals the mass of the products. So the number of the atoms in the reactants must equal the number of atoms in the product side. So we can clearly see here that we have an imbalance with our oxygen. We have 2 hydrogens and 2 hydrogens on either side. We have 1 oxygen and yet 2 oxygens. So that's our imbalanced area there. That's the first thing we're going to be looking at. Remember, the general rule is to first of all balance anything other than hydrogen and oxygen, then go to hydrogen, then go to oxygen last. But as we have only hydrogen and oxygen, I'm just going to look at what's imbalanced and start from there. So, to get the reactant oxygen atoms equal to the product oxygen atoms, I would just simply need to multiply by 2. So now I've got 2 oxygen atoms and 2 on the reactant side and 2 on the product side. So that 2 is going to be my coefficient that I place in front of my water molecule. But because I've multiplied, or I now have 2 water molecules over here, I've not only multiplied the oxygens, I've also multiplied the hydrogens. So I have 2 times 2 hydrogens giving me a total of 4 hydrogens here, and I can see that when I do go down to my reactant side. I have to, because I multiplied my oxygen and these are combined into one molecule, I have to multiply my hydrogens here, which gives me 4 hydrogens. So now I've created a further imbalance when I balance my oxygens. I've created this imbalance between my hydrogens. I've got 4 on the reactant side, 2 times 2 equals 4 total, and I have 2 on the product side, 2 hydrogens right there. So I need to multiply this by 2 to also equal 4. So that's, oops, making a mistake there. Let me fix that one. Multiply it by 2 to give me 4. There we go. So now that 2 is what I need to put in front of my hydrogens here to multiply that up. So I can see that the balanced chemical equation now is 2 water molecules reacts to give 2 hydrogen gas molecules plus 1 oxygen gas molecule. Okay, again, 2 times 2 hydrogens is 4, 2 times 2 hydrogens is 4, 2 times 1 oxygen is 2 total, and 1 times 2 oxygens would be 2 oxygens total. So now we have that balanced chemical equation. So if I move down here, I'm going to skip through all that and move on to the next sheet so we can look at it in a different light. So we're just going to do what I call the trial and error. I just find this one easier because I just look at each individual atom, or sometimes I look at the polyatomics, and I just go back and forth to make sure that it's overall balanced. Now, if we remember the general rules, we leave hydrogen and oxygen till last. So I'm going to start with my sulfur. Having a look here, I have 1 sulfur. Over this side, I have 1 sulfur, so my sulfurs balance out. Over here, I have 4 times 1 fluorine, so I've got 4 fluorines total there, and I've only got 1 here, so I need to put the coefficient in front of the molecule. I can't put it next to the fluorine or in front of the actual fluorine, or I'm going to change what the formula for that compound is, and I cannot do that. I can only change the number of these molecules I have. So I have 4 of these molecules. If I write that out, there's 1, 2, 3, 4 of those molecules. So if I have 4 of those molecules, I have 1, 2, 3, 4 fluorines altogether, which is the same on my other side. That's why I use the coefficient 4 in front of it there. So let me just get rid of that now. So now that I've done my fluorines, I'm going to go and look at my hydrogens. That's the next thing. If we have a look, sulfur I've not changed, fluorines I have changed, they're fine. I'm now going to look at my sulfurs to make sure I have the right number. My hydrogens. So if I look here, I've got 2 hydrogens on this side, but I've got 4 times 1 there, so I've got 4 hydrogens on this side. So to make it 4 hydrogens on there, I need the coefficient of 2 to multiply out my subscript to make 4 hydrogens total. So inadvertently, I've also multiplied my oxygens, but let's have a quick look now. 2 times 1 oxygen gives me 2 oxygens total. And over here, on the product side, I have my 2 oxygens. So this is now a complete balanced chemical equation. What I'm going to do is I'm going to erase that now, and I'm going to go through that the other way with that chart. So if I have a look back at the chart, we have elements, reactants, and products. So I'm going to quickly write that one out on this side here. So elements, reactants, products. So looking at down the list, I start with sulfur, then fluorine, then hydrogen, then oxygen. Those are my different elements there. Just reading sulfur, fluorine, hydrogen, oxygen. No particular order, it's just the first ones that I see. I'm going to write down now the number of, in the reactants I have 1 fluorine, 1 sulfur, 4 fluorine, 2 hydrogen, 1 oxygen. Looking at the product side right now, I have 1 balanced. I have 1 fluorine, obviously unbalanced. I have 1 hydrogen, again obviously unbalanced. I have 2 oxygens, again unbalanced. So how do I do this? I'm going to start with the first one that's unbalanced, which is my fluorine. I'm going to multiply that by 4. Now because I've multiplied this by 4 here, and the fluorine is connected to the hydrogen in the molecule, I now need to multiply this by 4. So that equals 4, which makes me balanced. This equals 4, which makes me unbalanced. So I have to multiply this by 2 to equal my 4 and create that balancing. If I look at my oxygen, because I've multiplied my hydrogen here by 2. The hydrogen is connected to the oxygen in the water molecule. I also have to multiply my oxygen here by 2, which equals 2. So that gives me balanced sulfur, balanced fluorine by multiplying the product 1 by 4, balanced hydrogens by multiplying the reactant water molecule by 2, and the product hydrogen fluoride by 4, balanced oxygen by multiplying by 2, because I have 2 on that side. So I can take those coefficients that I've multiplied them, those coefficients which are multiplying the molecules, and stick them into my balanced chemical equation. So looking at my fluorine, 4 on the product side. So there's my 4. Hydrogen, 4 on the product side, 2 on the reactant side. So there's my 2. Oxygen, 2 on the reactant side, there. And now I'm balanced. So those are the 2 different methods for balancing chemical equations. The trial and error, just counting and going back and forth, or if you like more of that visual look at it overall, you can draw out this table and work it through this way as well. Both are acceptable. As you get more proficient, I would hope that you get to the trial and error way just by looking and going a bit quicker. I find that one a bit quicker, but that I'm a little bit more experienced. So I'm going to leave you now to do some more practicing by yourself, and the second tutorial will take you through some also, just in case you're still having difficulties with this.